Hello everyone, so the question we have is in which mode of expression the concentration of the solution remain independent of temperature, right? So we have four options given here. So first of all, if we talk about molarity, right? So molarity is 1 upon V, right? It is inversely proportional to volume. And from the ideal gas equation, that is PV equals to nRT, we can say that the volume is directly proportional to temperature. So it is in molarity should be inversely proportional to temperature according to this. So molarity depends on temperature. So this should not be dependent. Now talking about normality, if we talk about normality, so normality, it is actually molarity into n factor, right? Molarity into n factor, and we have seen that molarity is depending upon temperature. So normality does not depend upon, it is also dependent upon temperature as normality is depending upon molarity. Now, if we talk about formality, right? So formality. So it is the number of gram formula masses dissolved. So we can write number of gram formula masses dissolved, right? Divided by volume in liter, right? Divided by volume in liters. So we can see that it is formality is depending upon volume, and volume is directly proportional to temperature. So it is also depending upon temperature. So this is not correct. Now coming toward molality. So if we talk about molality, so molality is one which depends upon the mass of solute and the solvent, right? So the mass of, if we talk about molality, so it is mass of, or you can say moles, better, right? So we can write that uh, molality is one which depends upon mass of solute, mass of solute, right? And and the solvent, right? Solvent in kg. So the mass is independent of temperature, we know. Thus molality, it is actually independent of temperature. So our correct option is option D. Thank you.
The question is, a molar solution is one that contains 1 mole of a solute in, and these are the options. So 1000 grams of the solvent, 1 liter of solvent, 1 liter of solution, or 22.4 liters of solution. So this molar, it comes from molality. So this molality is defined as number of moles of solute per kg of solvent, and it is expressed as m is equals to number of moles of solute divided by the mass of solvent in kgs. So a molar solution, it means 1 molar solution, or we can say 1 mole per kg. So in 1 molar solution, there will be 1 mole of solute in 1 kg of solvent. So 1 kg, which is equal to 1000 grams. So a molar solution is one that contains 1 mole of solute in 1000 grams of the solvent. So our correct option will be option 1, 1000 grams of the solvent.
Our question is 0.50 mole of BaCl2 is mixed with 0.20 mole of Na3PO4. The maximum number of moles Ba3PO42 that can be formed is, the reaction is here, BaCl2 react with Na3PO4 and it will give Ba3PO4 twice plus NaCl. Balance the equation. Here 3, here 2, here 1, and here 6 here. As we see that in this reaction 3 moles of BaCl2 react with 3 mole of BaCl2 react with 2 mole of Na3PO4 and to give 1 mole of Ba3PO4 twice. Okay. So from here we can given we are given here it is given 0.50 mole of BaCl2 is mixed with 0.20 mole of Na3PO4. Okay. So 2 mole of Na3PO4 will give 1 mole of Ba3PO4 twice. As we see that here Na3PO4 is a limiting reagent. Okay. So 0.2 mole of Na3PO4 will give 0.20, sorry. 0.20 mole of Na3PO4 will give equal to 1 into 0.20 divided by 2. On solving this, it is equal to 0.10 mole of Ba3PO4 twice here. So 0.2 mole of Na3PO4 will give 0.10 mole of Ba3PO4 here. So let us see the maximum number of moles of Ba3PO4 that can be formed is 0.10. So option 1 is the correct answer of this question here. Option 2 is not correct. Option 3 is not correct. Option 4 is not correct here. So option 1 is the correct answer of this question here.
Hello everyone, this is our question. Let me explain it to you. When the same amount of zinc is treated separately with excess of sulfuric acid and excess of sodium hydroxide, the ratio of volume of hydrogen involved is. So in this case, we will be watching the reaction. First of all, zinc we are treating with excess of sulfuric acid. There is formation of salt, that is zinc sulfate, along with the liberation of hydrogen. Okay, so we can see in 1 volume of hydrogen gas we are getting it. On the other hand, if zinc is reacted with sodium hydroxide, okay, because excess we have to take, so again we've taken this here, okay, then we would be getting sodium zincate, that is again salt, plus liberation of hydrogen gas. So here also one volume of hydrogen is liberated. Hence we can say that when same amount of zinc is treated separately with excess amount of sulfuric acid and NaOH, then ratio of volume of hydrogen evolved is simply 1:1. Okay, so going above, option number A is correct. Thank you.
Hello students, the question given is the total number of electrons in one molecule of carbon dioxide. Okay, we have to calculate the total number of electrons. So first of all, what is carbon dioxide? Carbon dioxide is CO2. Okay, in carbon dioxide, what we have? We have one carbon plus two oxygen. Okay, so now we have to calculate total number of electrons. We know that on carbon we have how many electrons? 6 electrons on carbon, because the electrons, number of electrons is equals to the atomic number Z. Okay, the atomic number of carbon is 6, so the atomic number of carbon is 6, that's why electron is also 6. So here one carbon means we have 6 electrons. Okay, plus we have 2 oxygen, 2, and each oxygen, we know that electrons is equals to atomic number. In case of oxygen, the Z is 8, because atomic number of oxygen is Z. That means electrons on oxygen is 8. Okay, here we have 8 electrons, and how many oxygen? 2 oxygen. It means we have to multiply with 2. Now total electrons is here 6 electron plus 16 electron. Okay, and total is 22 electron on CO2. Okay, so total electrons on CO2 is 22 electron. Okay, This is the answer. So let's see which option is correct. 22 electrons means option A is correct, option B is wrong, C is also wrong, D is also wrong. So only correct option is option A. Thanks.
Hello students, let's start the question. The question says that a gaseous mixture contains oxygen and nitrogen in the ratio 1:4 by weight. Therefore, the ratio of the number of molecules is. Now, what has been given to us? The ratio 1:4 by weight, isn't it? Yes. So, in the mixture, the ratio by weight is oxygen upon nitrogen is equal to 1/4. Yes, okay. Now, what is the atomic mass of nitrogen? The atomic mass of nitrogen is 14. Yes, hence N2 will be 28 because in gaseous state it is diatomic, right? So the N2 molecule would have 28 units mass. Yes. Similarly, the atomic mass of oxygen is how much? 16, which implies that again oxygen is also diatomic in gaseous state. So its mass would be 32. Yes. Now, according to these masses over here and the ratio by weight which has been given over here, let us incorporate it and give the ratio in terms of atomic masses. Okay. So ratio in terms of atomic masses will be what? It will be equal to 1/32 is to 4/28, isn't it? Yes. So that is for oxygen is to nitrogen, which we were talking about, which is 1:4. So this would be for your oxygen, this would be for your nitrogen. Yes, okay. Now, proceeding further, since the atomic masses have already been given, we can now give it in the terms of number of molecules. Yes, Avogadro number. Yes, if you remember well, this mass which is there, that is 28 and 32, is the mass of Avogadro number of molecules, isn't it? Yes. So, come on, let us proceed and give the ratio in terms of number of molecules. Yes. So, Avogadro number of molecules is going to weigh this much. So, it's going to be 1 into Na upon 32. Yes. Is to 4 into Na upon 28. Again, that would be for oxygen is to nitrogen, right? Yes. Now, accordingly, we know well that number of molecules is what? Number of moles into Na. Yes. The actual number of molecules which we have to find out in the given ratio. So, the number of molecules is equal to the number of moles into Na. Yes. Fine. So, in that case, what we do is we cross multiply. That is oxygen upon nitrogen is equal to 28 into 1 into Na upon 4 into Na into 32. Yes. Na gets cancelled. This would be 7 and this will give me 7/32. That means 7:32 would be the ratio of the number of molecules. Are you getting my point? Yes? Fine. So this part was number of moles into Na and accordingly we derived our ratio. Yes? Okay. Well, I hope you understood this calculation. Yeah. So we are marking option number 4 as our correct answer. Thank you.